This is the video for 2.2, subtracting rational numbers. The additive inverse means that two numbers, if we call them just a and b, satisfy the equation a plus b equals 0. So what this means is any two numbers, if I add them together and they equal 0, it makes them additive inverses. For example, 3 and negative 3. When I add 3 and negative 3, I get 0. 12 and negative 12. When I add those together, I get 0. So 12 and negative 12 are additive inverses. So the identity means that 0 is the additive identity for rational numbers. Adding 0 to any rational number results in a sum identical to the original. So I can also add 0 to any number and it'll still be the same. So 0 plus a, for example, if I was to put 4 in there for a, 0 plus 4 then would equal 4. Okay, we're going to use both those two ideas here when we come down to our sample questions. So when I go to subtract, it's the same as, has anyone heard of keep, change, change? I want to get rid of that vocabulary. When I see a subtraction, I want you to think of it, it's the same as adding the inverse. Okay, so no KCC, because a lot of people just blurt that out and they don't know when to actually use it, versus fractions or decimals, and then we get all of our rules mixed up. So get in the habit of thinking of subtraction means the same as adding the inverse. So in this problem, for 6 minus 8, I know 8 is bigger than 6, so I can't subtract these like normal. It's going to be negative. I can think of that the same as being 6. Instead of minusing, I change that to add. The inverse means it's the opposite, so negative 8. So for example, right, we said 3 and negative 3 are inverses. 8 and negative 8 are inverses. So when I change this to an add, I need to change that 8 from a positive to now it's a negative. Then I go back to my rules. If I had 6 and I add 8 bags of sand to it, it's going to drop it down below. So if I was at 6 and I go down 8, I go past 0, 2 more, I'd end up down at negative 2. Okay. If I was at negative 5 and I wanted to subtract air, isn't that the same as being at negative 5 and adding bags of sand? Anytime I see a minus sign and I'm working with integers, I can think of it as like leaving the first one, but instead of subtraction, I can change it to add, and then I make the second one the inverse. So I'm at negative 5. I'm supposed to go down 9 more negatives when I subtract. That's the same as adding negative 9. I'd end up down at negative 14. Okay. What happens then if I subtract the negative? We said the inverse means that I add them together and I get 0. So the inverse of a negative then would make it positive. So this time, if I go to subtract my negative, that's like removing my bags of sand. It brings that hot air balloon back up in the air to positive. Instead of minusing, I can change it to add, but my inverse of that negative is to bring it to positive. Just as a reminder though, I do need common denominators before I can add my fractions. So even though I got rid of my subtraction sign, I do still have another step here. I'm going to go ahead and leave 5/8 the same, but in order to make my second fraction also be out of 8s, I need to make common denominators. If I take 4 times 2 to make 8 on the bottom, on the top I have to take 3 times 2 as well. Now I can add. I have a pizza cut up into 8 slices, so that stays the same. I never add the bottom for fractions, but I add 5 slices plus 6 slices makes 11. And then, I still have one more step. I have 11 slices when each piece is only cut up into 8s. So I could make one full pizza. 11 slices minus the 8 would leave me with 3 left over. Okay. Feel free to pause it if you need to go back and add any more steps or work to there. All right, our next one, we're at negative 1.2, and I'm supposed to subtract a negative. Removing bags of sand is the same as my hot air balloon going up. My additive inverse says instead of a minus, I can change that to a plus, but I also have to change this sign, so that also becomes a plus. So now I'm in the whole negative 1.2, and I'm supposed to be adding 1.3. I usually rewrite it if I have to do a couple different changes with my signs. So now let's just look at it from here. If I'm at negative 1.2 and I'm adding 1.3, think like yesterday, these two have different signs. One is in my negative, I'm going to go up past 0 and then keep going up. So I know my answer, 1.3 is bigger, should end up in the positive. but I need to subtract these two numbers to figure out how much I'm left with up into my positive. So I'm going to go ahead and put my bigger decimal on top. The order here, remember when I add, I can always add them in different orders. So I'm going to go ahead and put the big one on top. 3 minus 2 is 1. 1 minus 1 is 0. My decimals were stacked, and I put the biggest decimal on top when I go to subtract them. I was in the whole $1.20. I came up $1.30. So I came up past 0. I kept going. My final answer should be a positive 10 cents. Again, a couple reminders. Make sure that if you minus and negative, we'd change it to additive and the inverse. So I would recommend rewriting that problem. Also, your bigger decimal does need to go on top if you would like to subtract those two decimals. Okay. Let's try one more over here. I'm supposed to have a negative, but again, I'm subtracting. Anytime I see that subtraction and negative, I'm going to go ahead and do my additive inverse. So instead of subtraction, I'm going to say add. The inverse of negative 2 4/5 would be a positive 2 4/5. So I'm going to go ahead and rewrite it. I got negative 3 2/5, and then we're plus 2 4/5. Okay. Before I add these two, though, always double check. Do I have the same signs? In this case, I was supposed to be in the whole $3, and then I'm plussing 2. So I'm going in opposite directions. I should come up towards my positive, but my answer should not be up in here towards like a negative or a positive 5. I was in the whole $3, and then I gained 2. So my hot air balloon came up, if you like that analogy, and I should end up closer to a negative 1. So even though it says plus, I have a negative and a positive, so I'm going to go ahead and subtract those two. I cannot do 2 minus 4, though, unfortunately. So I'm going to borrow. I'm going to take away one whole pizza and make that 2. And since I already have fifths, I'm going to cut my whole pizza up into 5 out of 5 slices. So when I regroup, I can take away one whole and add the whole 5 out of 5. I already had 2, though. So 3 2/5 is the same thing as 2 and then 7/5. Now I can subtract. 7 minus 4 is 3. My common denominator will stay the same. And 2 minus 2 is 0. Before I circle this as my final answer, always ask yourself, is it supposed to be positive or negative? I was in the whole $3, and then I paid you 2. So I came up 2. I should still be in the whole about $1. So my final answer is negative 3/5. Put in A to be negative 3. So in this equation, I'm going to go ahead and put my negative 3 right there where I see A. And my B is supposed to be 2. Be careful though, it's supposed to be a minus sign. So I'm going to go ahead and minus my B, which is 2. I see a subtraction sign in integers, so that's my reminder. I'm going to do the additive inverse. Instead of minusing, I need to add, but that changes this to be the inverse and make it negative 2. So I have negative 3 plus negative 2. I'm already negative, and I'm adding more sand to bring it down. That takes me even further down to negative 5. Okay. You can also think of it like 3 negatives and then plus 2 more negatives if you're a person like integer chips. Okay, let's try another one. 4.2 and 6.5. I'm going to go ahead and put my 4.2 right here for A. I still have a minus sign, so make sure I put that minus sign in there. And then B is negative 6.5. I used parentheses because I didn't want it to look like a minus and a minus sign. B was a negative 6.5. So I kept them separate. This is a minus and a negative 6.5. Since I have a minus sign, though, I do need my additive inverse again. So I'm going to leave the 4.2. I changed my subtraction to an add. The inverse of negative 6.5 is positive 6.5. So I'm looking for 4.2 plus 6.5. Decimals I need to stack on top. I'm always in the habit of putting the bigger decimal on top just in case I need to subtract them. In this case, we're going to go ahead and add. So once my decimals are lined up, I don't need to add any zeros. I can just go ahead and add straight down this time. 5 plus 2 is 7. 6 plus 4 is 10. And my decimal comes straight down. I had $4.20 plus $6.50 would give me a positive answer of $10.70. Last thought, these bars right here mean absolute value. Absolute value is the distance from 0. So remember, we're supposed to solve anything inside of here first, and then we can find our absolute value. So 12 minus 5 is 7. My absolute value bars come down. 7's distance away from 0 is still just 7. If inside my parentheses, or inside my absolute value bars, I had a negative 7, I treat them like parentheses and solve this first. If there was a negative 7 inside, that distance would as well be 7. So my absolute value will always result in a positive answer at the end, but I need to solve the inside of that first. One more. Trickiest one on here. I do not have common denominators, so I need to go ahead and solve this inside part first by making common denominators, then we'll deal with our absolute value bars. My common denominator between 8 and 12, I would not recommend making it 96 and timesing them by each other. I do have a smaller one, and I'm going to make them both be out of 24. So in order to get from 8 to 24, I took that times 3. I went across my multiplication chart for 8 and across the line for 12, and I saw they had 24 in common. 8 times 3 is what made the 24, so I need to do that to the top. 7 times 3 is 21. For my 12 times 2 is what made the 24 in the multiplication chart for that one. So 3 times 2 would make 6. I'm left with negative 21 plus 6. I'm at negative 20 on my number line, and I'm coming up 6, so that is in the opposite direction. It should leave me at a negative 15. You can also think of it as their different signs, so I need to subtract them, or you can go ahead and draw out the minuses and the pluses if that helps you too. One last step though, I need to simplify this before I deal with my absolute value bars. 15 and 24, I can both divide by 3. I always check for 2, 3, and 5. 15 is not even, so I can't divide by 2. And 24, I can't divide by 5 because it doesn't end in 5 and 0. But I can divide these guys both by 3. So inside my absolute value bars, I'm going to be left with negative 5 over 8. Now I can deal last step with that absolute value bar. The distance from 0 is always positive. I can't go negative distance.